Right, so determining a radical function from a graph. Maylene is designing a symmetrical pattern. She sketches the curve shown and wants to determine its equation and the equation of its reflection in each quadrant. The graph is a transformation of the graph of y equals the square root of x. What are the equations of the four functions Maylene needs to work with? All right, so when we are writing the equation of a square root, we want to consider what a is, what b is, what h is, and what k is. And this will be the format for our equation. Y equals a, where a is a vertical stretch. B is the horizontal stretch. H is a horizontal shift. And when I say stretch, by the way, it could be stretch or compression. And K is the vertical shift. All right, so let's think about our parent function. So we have y equals the square root of x. And these are the points that we usually see. Actually, let me write this a little higher. All right, we plug in 0, 1, 4, 9, and we get out 0, 1, 2, 3, right? The perfect squares and the roots. All right, so now if we look at, so A affects y, all right? So this is affecting y. This is affecting x. And then we'll talk about shifts. All right? So if we look at our parent function, let's graph our parent function here. 0, 0, 1, 1, 4, 2. And that's really all we can fit on this particular graph. Oh, and let's connect. All right, so we notice there's a different slope to it. First thing I noticed, though, is look at your x values. Your x values are still lined up with the parent function, right? Those points aren't any farther to the origin. They're not any closer to the origin. They're lined up exactly where they were before. So the horizontal stretching and compression is your b, and there's no change in that, right? We have a point at 0, we have a point at 1, we have a point at 4, and that's exactly what we see here, right, for the x values from the parent function. So that means that b here for this first graph is 1. How about a? All right, well, the a values aren't the same. All right, so instead of, and let's compare here, our y values aren't the same. So we still have 0, but instead of being at 1, we're at 2, right? This is the point 1, 2. Instead of at 2, we're at 4. This is the point 4, 4. So notice you can see that the new y values, the y values for that the graph that's shown is twice as much. So that means that our a is 2. Our endpoint here is still at 0, 0. So there's no horizontal shift or vertical shift. So h is 0 and k is 0. So now that we know that information, we can write the equation for our graph here. The one that's shown in the first quadrant, because she wants it in all 4 quadrants, we're going to replace a with 2, and that's it. And h and the rest of them are 0 or 1. We'll write it all out, and then we can just simplify. So y equals 2 times the square root of 1 times x minus 0 plus 0. Well, that's just y equals 2 square roots of x. And that's the equation for the graph that's shown. All right, so now, but she wants to reflect it into the other 3 quadrants. Right? So I'm going to just clone this page just to give us some place to write. All right. So that's what we have so far. All right, I'm going to erase this because we have it on the other page. All right, so she wants a reflection in each quadrant. All right, so now the next graph is going to be, and I can only draw a little piece of it, but the next graph is going to be over here and here, and if I can extend it a little bit. So it's going to be right here. All right, so notice now our y values are the opposite. So that's going to change A. Right? So if our graph is here, A is now not 2, but negative 2. Right? And that's because we are reflected over the x-axis. So that means, and that's for the 4th quadrant. I did them out of sequence, but we'll do the 4th quadrant next. Seemed like the easiest one. All right, so now we have y equals negative 2 square roots of x. And I don't think we need to plug in the 1s and the 0s. All right, now what if we want the graph? Let's put it over here now. All right, so we want it in the 2nd quadrant. All right, so we're still going to be at 0, 0. But if we're reflected over the 2nd quadrant, we're going to have a negative x value instead of a positive x value. Right? So now, what would make our x values the opposite? All right, so this one was for, I should put, this is for the green graph right there. This one is going to be for the red graph. All right, and that is, we're going to need b to be negative 1. Right? That will cause us to reflect over the y-axis. I need a little bit more space here. So if b is negative 1, we have a reflection over the y-axis. So that means for the 2nd quadrant, I don't know why, I did some in Roman numerals and I did some, I'll just make them all the same. 4th, 2nd. So for the 2nd quadrant, we're going to have y equals, now our a is going to be, and I'll write it in there, a is still 2, it's still stretched, but it's no longer negative if we're in the 2nd quadrant because our y values are positive. So we have y equals 2 square roots of negative x. That will give us x values that are the opposite. Well, now what if we want to be here in the 3rd quadrant? In other words, we want to be reflected over both the x-axis and the y-axis. And so if we want to be reflected over both, right, then I'll put it here. A is going to have to be negative, and B is going to have to be negative. And this will cause us to reflect over both axes. So that means that in the 3rd quadrant, the equation would be, we'll have both the negatives in both places. Y equals negative 2 square roots of negative x. So now the x's are the opposite and the y's are the opposite. And that's really all there is to writing the equations of radical functions. You're going to look at I always look to see if I'm horizontally stretched first. Right? Are my x values where I expect them to be? Then I check to see if we're vertically stretched. Are my y values where I expect them to be? Right? And then we can look for, are we shifted at all? Are we shifted horizontally? Are we shifted vertically? Right? And those are the steps we'll take to write the equations of graphs of radical functions, and specifically square roots. Whoops. So I got my pages out of sequence. This one was supposed to be first, There we go. And this one was supposed to be second when we wrote all the equations. Let's write the equation here. All right, so first of all, let's graph the parent function. As a reminder, the parent function is y equals the square root of x. And this one, by the way, is not in your notes. The other one was. Our x values are 0, 1, 4, and 9. Our y values are just the square roots of those points. All right, so now if we graph that, we could almost fit the next one in there, 16, couldn't we? Because this is a pretty stretched out graph, or horizontally, there's a lot of graph here. So let's graph our parent function. There's 0, 0, and 1, 1, and 4, 2, and then 5, 6, 7, 8, 9, 3. No, we couldn't get 16 on there. Almost. So there's our parent function. All right. So I notice, first of all, this one starts at 0, 0. And I notice this one starts at 1, negative 2. So they don't have the same starting places. But let's see if I get the expected x and y values. Now, if you've been shifted, right, obviously your x and y values are going to change because you've moved the graph right and left. But let's see if the change is consistent. So here, if I'm looking at my a value, if we look at our a values, our b value, our x values, so that we can compare, so we can figure out b. Sorry about that. So notice here we go up by 1. Well, that's what I expect, right? We go up by 1 because we go from 0 to 1. Now the next one, we're going to go up by 3, right? Because I'm going to go from 1 to 4. And then 4 plus 5. So this was 1, this was 3, this was 5. That's how much our x values are going up by each time. How about for the graph that we want to write the equation for? All right, so I went over by 1, not up, excuse me. If I said up, sorry, we went, so notice that the distance here between perfect squares is 1. The distance here between perfect squares is 3. The distance here between perfect squares is 5. So you see we have the exact same shape horizontally. How about vertically? All right, so vertically, right, we go up to the next value. As a matter of fact, we keep doing that, right? We keep just going up 1, right? The square root of 0, so our y values increase by 1 each time. Right? Our x values are a little bit different, but the y values increase by 1. Well, let's look here. Increases by 1. Oops, put it in the wrong spot. Increases by 1. Increases by 1. Increases by 1. So A is 1, and B is also 1. There's no stretching, right? So there are no stretches and no reflections. But there is a change to h and k, right? Because we've been shifted 1 to the right, right? H is 1. And that's in our equation will be x minus 1, right? Because the negative is already in the equation. And we're shifted 2 down, so k is negative 2. That means the equation is y equals 1 times, and I'll fill in the 1s and the 0s and anything that has no impact, just so you can see where everything goes. So y equals 1 times 1 times x minus 1, a lot of 1s, and then it was minus 2. Well, I don't need the a value being 1. I don't need to write in 1 for the a value or the b value. I can just say y equals the square root of x minus 1 minus 2. And there we have the equation for that graph. All right, let's try another one. I have a couple of them, not a lot, but a couple. So that one had no stretching, but it did have a shift. And that one wasn't in your notes. And actually, this is my last one. Why does that look so pixelated? All right, so, and it's not the above graph. It's the graphs are below, but that's all right. So we're going to write the equations of these graphs, and we're going to do it the same way. We're going to look to see if our graph is horizontally stretched, or reflected horizontally, is it vertically stretched, or reflected vertically, etc. Shifted. All right, so here, remember our parent graph. I'll put that in once for both graphs. Y equals the square root of x. All right, and 0, 1, 4, 9, and 0, 1, 2, 3. Right, the perfect squares and the square roots. All right, so when we're looking, let's look for A. So A, notice the distance between our values, right? Right, we go, excuse me. Look at the distance between our y values. All right, so we're expecting to go up 1 each time, but we actually go from 2 to 5. So we go up 3. And then from, we should go up by 1 again. We go from 5 to 8. Again, another 3. All right, so we are not going up by 1 each time on the y. We are going up 3 times as much. All right, so that's our A value. Our B, let's look to see if our graph is stretched or compressed horizontally. We should go, right, actually I'll put it over here. So we should go to the right 1, right, and then so I'm looking right here, so 1, and then 3. So I'm just going to put it up here, 1, 2, 3, and I don't have any more points here on this graph, do I? Oh, I think I can see. I think it's that one right there. And then we go up from here to here by 5. So 1, 2, 3. Now that wasn't one on the graph. So it's actually one more. Almost, but we don't have the next point. But we can see from those two, we're going up by the amount we expect. So that means that B is 1. This is our H and this is our K. So let's put that in red. So H here is 4, so that'll be x minus 4, and K is 2. So that means the equation of this graph is y equals 3 times the square root of x minus 4 plus 2. All right, and that's all there is to it. Let's look at the next one. All right, so first I noticed that we're reflected, and we're reflected over the x-axis. And so, because we're below the x-axis. So that means that A is going to be negative. All right, let's check and see if our graph is vertically stretched. So I should go up by 1 each time, and instead I'm going up by 2, right? From -4 to -6, from -6 to 8, from -8, from -8 to -10. So notice that we're decreasing by 2 each time. We're reflected over the x-axis. A is -2. How about our B values? All right, so we're going up by, I'm going to put this, we're going up by 1. There we go. We're going up by 3. We're going up by 5. Just what we expect here, right? We increase by, let me get rid of this. We increase by 1. We increase by 3. We increase by 5. So, and we're not reflected over anything. So B here is 1. And then let's look at our point here. This point is at -3. Is it -3, -4? So this is our H and this is our K. So our H, I'll just write blue. Our H, I guess I should have written this in blue too, huh? Our H is -3, so that's going to be x plus 3, right? Because that would be minus a negative. And our K is -4, so that means our equation is y equals -2 square roots of x plus 3 minus 4. And there's our equation. That's all there is to it. Right? So you really don't have to solve. You need to analyze. Right? And I give you good points that you can analyze with it. One thing we really didn't see on this graph is a whole lot of changes in B. It might be nice. Oh, I have a change in. Do I have a change in B here. Nope, not a change in B. But let's look at a change in B. And I'm just going to grab a coordinate plane. So I can just graph one just so you can see changes in B a little bit more. It just seems like it's hard to find. Oops, let's see if I can do copy and move over. And I may change my mind about that one. I'm not sure. Ah, it won't let me paste. That's weird. Oh, well. Oops, now I'm caught on my cord. It won't let me paste it in. So, while I'm recording, it's weird. My recording box is on a totally separate screen, and it won't let me paste it in. And I don't have any way to get that in there. So I tell you what, I'll put it in on the next video. So we're going to end this video right here with this graph. And on the next video, we'll look at a graph and we'll look at a word problem. All right, so thanks for watching, and I'll see you later.